This is section 1.
Yeah. All right. Yeah.
I didn't understand the difference between linear and quadratic.
Linear is anything with, so something like this. Let me just throw something at you that's really freaky looking. This shouldn't throw you off too much. We've seen expressions with more than one variable. This is an equation. It doesn't really matter. If somebody just tells me what x and y are, I can solve for z, right? You guys with me? So that's not that big of a deal. All of the variables, though, are to what power?
1 first.
Every single one of them is to a first power. This is linear. If the only exponent on your variables is a 1, then it's linear. The minute you get anything else, now quadratic, to be more specific, quadratic would be the highest power you see is a 2. So it'd be like a second degree polynomial. So this would be a quadratic equation. Because the highest power I see there is 2. You guys see that? So you see the difference. This is linear. This is quadratic. So if I had, for example, if I had this equation here, how would you solve that?
Set it equal to 0.
Careful.
Okay.
I like it. Yeah, get x by itself, right? Get your x's together. Why do you not have to do anything weird like get it equal to 0? Because the highest power I see is a 1. It's a linear equation way back in chapter 2. In fact, if I remember correctly, the title of chapter 2, if you look back in your book, the title of chapter 2 is Linear Equations. Right? And at the time, you guys are all like, whatever they call it, crap, I know how to do this.
Right.
So that's why we call it linear, because every single variable, there's only one of them really, but each of the x's has a 1 on it. So I don't have to do anything weird. Solving this should be easy, and it is. Subtract x, -7 equals x. Done. Cool? The minute I do something like this, like what, Joe? I don't know. Oh, let's see. You can do it. Yeah. Get that out there eventually.
Right.
The difference there is what?
The 2 squares.
Yeah.
Squares.
So I know how to solve equations with one variable where it's a linear equation, right? This was an equation that had 3 variables. Let's not go to that. I would need 2 other equations to be a little system of equations. Let's not do that. If it's a linear equation with 1 variable, that's chapter 2. Easy. If it's not linear, if it's quadratic, meaning that I have a 2, that's the highest power I see. I can't solve it the same way, can I? Can you put your x's together? Can you subtract the 2x and put it together with that x squared and actually get them together? No. They're not like terms, right?
Can we
Okay,
write
cool.
it?
So there must be a different way.
We write it with x squared plus 2x.
Get it equal to
0.
0. Sweet. That's the trigger. That's why they want to make sure that you can identify, is it linear? And really, you don't have to do all that. You don't have to know the name. All the variables have just a 1 on them, 1 power. Yes, solve it like normal. Any variable have a higher power than 1. More specifically, normally a 2 for us, so it would be quadratic. Yes, oh shit, then get it equal to 0. Because there is no way to get x's together, right? So I need a different way to do it. So if I do get this thing equal to 0, what I have to do, I have to minus 2x, minus 24, right? Is that cool? Because I want this side to become 0, because there's nothing left over there. And on this side, I just get all this stuff. X squared minus 2x minus 24. And thankfully, I thought about this correctly in my head. It's we're trying to make a problem in your head where you got to think ahead of what's going to be when you take it over the other side. But how does that factor now? Beautiful. I know x squared is x times x. To make negative 24 and also negative 2, yeah, good. Minus 6 plus 4. Feel a little better. Fill it up a little bit.
subtract the x squared though? If you need one on the right side, you have to go
You
to the
could,
left
but
side.
then I'd have a negative x squared, which would be, I'd actually have to do surefire to make my signs come out correctly. I'd rather keep the x squared positive. You guys see that? All right. And then what's the answer though? How many answers will I get? And why does that make sense? Second power, I should expect at most 2 answers. In reality, like we talked about last time, there will be exactly 2 answers, but it might be repeats, it might be not real, which we haven't talked about yet. Don't worry about that yet. But I expect at least 2 real answers. Or 2, at most 2 answers. That's what I'm trying to say. So x minus 6 equals 0 or
x plus 4 equals 0.
That's the beautiful thing about the number 0. There are very few things that can multiply by 0. One of them has got to be 0. If you got a 2 over there or a negative 7, I'm screwed. I don't know. If it's a 0, then I know either the first dude's 0 or the second dude's 0. And what do you get?
X equals 6.
X equals 6 or
Minus 4.
x equals negative 4. I love it. Cool. Okay. Maybe.
Yeah.
All right. So that kind of took me off. That took me off on a review of everything. Any other specific questions before I get back into? I'll continue my little review. Okay, everybody's expectantly. Do the review, Jeff. So there's how you do the basic idea was called, I can't remember this book called, a zero product property is what it normally is called. To make a big deal out of it. Oh, I'm ahead of myself. This is section 6.5. And they call it in this book the zero factor property. I love it. Really all that says is if I have a number times a number is 0, then one of them's got to be 0. Right? If a number times a number is 4, does either one of them have to be 4? Does either of them have to be 2? No. It's an infinite number of things it could be. It's only 0 that really gives me specific answers here, right? Yeah.
Has it reduced to negative 3 and 2?
Well, it's not really a fraction. X is 6, right? Or X is negative 4. They're not over each other. I can't reduce them. If I change the number, then it doesn't work anymore. Only those numbers work. And how do you check your work?
Plug it in.
Plug it in. Plug it into the original. Don't plug it in here because you might have made a mistake along the way here. Always plug it back into the original. So like 6 would make this 36, right? 6 squared? Does that equal twice 6 is 12 plus 24? Yes. Right? And you can do the same thing with negative 4, plug it in. Okay. Yeah.
I have a problem on homework. Number 35, 3x squared plus 5x minus 2 equals 0.
3x squared.
Plus 5x minus 2 equals 0.
Coolness. Now, I hope you guys realize how many factoring methods have we talked about? I don't need a number, just there you go. And when the idea of solving an equation is you must factor to do it, you know they're going to use just about every form of factoring there is, right? Because we have to kind of get practice so we remember them. So what form do I have to use here? What method could I use here?
3 times negative.
Exactly.
Yeah.
Cool. I think most of the forms that you use, there's master product and all this kind of stuff. No bottoms up. Right? I'm still waiting for somebody to write me an essay about why it works, and then I'll let you do it as much as you want. Negative 2 times 3,
Negative 6.
negative 6, and then numbers to make 5.
Negative 6. Alright, 6 and negative 1.
6 and negative 1, right? Is that cool? They definitely multiply negative 6 and they add to be 5, because the big one's positive. What do I do with those two numbers now? Good. Rewrite the whole thing, just rewrite the middle. So 3x squared is still there. 5x is 6x minus 1x. And the minus 2 is still there. So I just took this and rewrote it. Because now what can I do? What's awesome about that? I can group. There's 4 terms. And grouping should be one of the easier factoring forms, right? Because now I take this group and that group. What comes out of these two?
X, 3.
Yeah, 3 and an x. X plus 2, I like it. What comes out of these two?
Minus 1.
If I don't take anything out, then that'll never be the same as this. So I need to take a negative out, negative 1. I like it. And then, of course, both of these change sign, and it becomes positive x plus 2, which is the same as that, thank God, or else I couldn't do the last step, right? Trust me, if you get these two numbers and they work, they do what they're supposed to do, this grouping must work. If you can't get those two numbers, it won't factor nicely, right? Let's use some advanced method we haven't got to yet. What's the last step here for factoring? And then we got one more step for solving, right?
X plus 2.
I like it. X plus 2 comes out. Left at 3x minus 1. And now I can say
That or that.
this guy is 0, or this guy is 0. This is really the first example that I can think of in this class that we solve something using an idea. I didn't really apply a step from here to here, did I? I used the idea of, well, they multiply with 0, so one of them's got to be 0. Which is kind of neat. The better you understand ideas, the easier solving equations becomes, because then you can kind of use both things. So I get here what?
Negative 2.
Negative 2?
1 third. Negative 1.
Yeah, exactly. Add the 1, divide by 3, 1/3. Cool. Some of you guys probably can get some of those answers quicker. Awesome. You don't have to necessarily show me some work. Be careful though, I often get people that think they get the answer and they tell me x equals 2 here. Negative 2, yeah, so okay. How do you guys feel about that? You understand now what I'm saying about if you don't know factoring, you can't do this section. Yeah.
6.5. 35.
How do you know when to do it like that?
I'm glad you said that, because what is it about this original problem that told me I had to do any of this stuff? The square.
Oh.
I can't get my x's together, can I?
No.
If that wasn't there, how would I solve that?
X by.
Add 2, divide by 5, I'm done. Right?
Yeah.
That being there, my x stuff can't go together. I have to have a different way to do it. Okay. All right. So that's section 6.5. I gave you a break on 6.6. That was the quadratic equation applications, which is the code word for word problem section. So you guys can thank me.
Thank you.
You're going to hit that in your next class.
Excellent.
And I think last time, if I'm not mistaken, we did get into section 7.1. And the idea with 7.1, again, it's all about being able to factor. Right? We started off with something like 4 over 20. How do I reduce that?
Oh, we'll go through the both.
Yeah, this is 4 times 1 over 4 times 5, right?
Right.
So the 4's cancel 1/5. So if I have something like this, oh, like what, Jeff? I don't know. It really almost doesn't matter how much I say this. Somebody's going to do this anyway. You cannot cancel these x's out. Can somebody tell me why I can't cancel this? There's an x and there's an x, Jeff. What the hell, man?
Because they're connected.
Careful, they are.
So you have the line expression.
Division cannot cancel anything out of a subtraction or an addition problem. They're not opposite operations, right? So if I have, like a little side note, if I have x plus y over x, can I cancel those x's out? No. Because division cannot cancel a part of an addition problem. Are division and addition opposites? Are division and addition opposite operations?
No.
Hell no. But if I had x, y over x, now what operation's up here?
Multiplication.
Now division needs that for lunch, right?
That's it.
They're opposite operations, so of course they cancel. If I just had this, how do I cancel the x? What operation would cancel the x?
Subtraction.
Yeah, because subtraction is the opposite of addition, right? Do you guys see that?
Yeah.
But it's so human. So I gotta let this go sometimes. It's so human to want to do that because it makes it look so nice. Right? Get some crap out of here. The y's left. No, but it can't. The division can't do that much. It can only cancel multiplication directly. Can't cancel part of an addition problem. It's the biggest mistake I see. I see this all the time. 4 goes into 12 3 times. Yay. No, you can't do that. I don't have a 4 up top. I don't know what the hell I have up top because I don't know what x is. So how do I do this weird problem?
Factor the bottom.
Yeah, factor whatever you can. The top I can't do anything with. Now, the really nice thing about very many of these problems in this chapter is the problems have hints in them. What do you think has to be a factor of the bottom here?
X minus 4.
It's got to be x minus 4 has got to be a piece of it, right?
Yeah.
So I can almost just put that down or realize 12 has got to be 4 times something, and of course it's 4 times 3.
-3.
And they both have to be negative to make -7. I don't know if you guys see that. If you don't quite see, there is a shortcut here with a lot of these problems. One piece might give me a hint for what the other piece needs to have. If you don't see that, just factor the thing. You got to be able to factor anyway. And then what cancels?
-4.
Careful.
Or x minus 3.
Yeah.
Well, that's what I meant.
And what's left?
1 over x minus 3.
I like it. 1 over x minus 3. Because where is the x minus 3?
On the bottom.
On the bottom. What's left when I do this divided by itself?
1.
1. And that's on the bottom, so be careful. Don't put x minus 3 as the answer.
Or 0.
Just like here, is the answer here 5?
No.
No.
But I get that a lot. 4 by 20 is not 5. It's 1/5, small. Same idea here. So how are we doing so far? Okay. So if you're able to factor, this section, this chapter should be actually easy. Because if you're able to factor, you just factor and then kill. Right? So remind me, how do I do something like this easier? There's an easy way and a hard way to do this kind of problem.
Cross multiply.
Careful now.
No? Oh yeah, so it's
Cross
not
reduce.
Yeah,
cross reduce, yeah.
Yeah.
It's not equal to
The only time you cross multiply is if I have a fraction equals
You're
a
right.
fraction. Then you can cross multiply. Here, this would be what goes into both of those.
3,
So you get,
3, 7.
and what goes into both of those?
8.
8, good.
Yeah.
8 goes into 56.
4, 5, 6, 7 times.
I like it.
Gotta be right eventually. Two.
Did you ever teach you to go, what is the answer? 4, 5, 6, 7, 8, and stop. You got it. Good job. And then 8 goes into 16
Two.
twice. So is everybody, I mean, this should definitely be old stuff, obviously. This is
Old
chapter
stuff.
1 stuff, review stuff. And then you get 6 over 49, because the basic operation is multiplication. Don't give me 5 over 14. Don't give me that. Multiply. So what do you think is going to happen now? Instead of a single thing over a single thing, we're going to have one fraction with variable expressions times another fraction with variable. It's just the same problem, just more stuff. You factor everything and then kill whatever's the same on the top and the bottom.
We still cross cancel.
Oh, hell yeah. Same thing we did here.
Great.
And just to really, I mean, these things are more difficult to work with because they're numbers we don't know. But they have to act just like these do because they are numbers. They have to act the same. They are numbers. So if I had a problem like this, all right, now I got to make one that works. Oh, let's make one interesting.
Oh, thanks.
Anytime. Let's see if that works out the way I want it to.
What's that?
I like it.
I don't
A
like
lot.
it.
Too bad.
I don't like it.
Would like that. Okay.
Totally.
Yeah, but don't bring in the thing.
So
You got a factor
here
problem.
is why those of you who don't aren't able to factor very well, you're really going to hate this section because that is 4 problems from chapter 6 in 1, right? Because
Yeah.
here is a what?
Difference of cubes.
Difference of cubes, right? You can have little dude, big dude. This is at least a
Trinomial.
GCF.
Oh, GCF.
Be careful, whenever you have a cube, don't you have a big dude that can't factor? So maybe some other three-term thing is going to be that big dude and they're going to cancel.
Yeah.
So don't freak out if this won't factor. He's going to die maybe
Maybe, yeah.
with the big dude. And that's actually what's going to happen. And this guy is definitely GCF. And this guy is a beautiful little difference of squares, right? Again, I'm not so curious about, I don't care really too much if you don't know the names, but you have to be able to identify them, at least know what method to use, right?
Yeah.
And of course, if you know the names, it's a little easier to associate a method with it. So how do I factor the top here?
X minus 3. X minus 3. Oh.
Good, so this is X.
X.
Careful now.
Yep. There you go.
So X minus 3, I like it.
And then x squared plus 3x squared.
Careful.
Plus 3x.
3x
Yeah, plus 9.
plus 9. The other two 3's go there.
Okay, it's the same.
So remember that?
Oh no.
Okay. Because you put one of each, and then 2x squared. 2x is there for x squared. 2 3's there for 9, and the middle one is this times this.
GCF, you take the X out.
X out.
Beautiful. Take the x out, and like we said,
X squared.
X squared
Plus
3x
3x.
plus 9. Yeah.
beautiful. So don't waste your time trying to factor these and going crazy. Just if you don't see it, let it go for a minute and see if it shows up somewhere else and go, oh shit, there it is. And then over here,
X 4. So you got
X minus 1.
I like it. X minus 1, I love it.
And then GCS. Can we take those out?
X minus 1 x.
There's no GCF here, right?
X minus 1 x
Can we
plus.
take X out?
Where? Here?
Squares.
Can you take an X out of here?
No.
No. GCF has to be able to come out of everybody.
X minus
But that's just a beautiful little difference of squares, right? X squared is x times x. 1 is 1 times 1.
negative
Minus
positive.
negative.
I like it.
Yeah.
Now look there, are we done factoring?
Nope. Oh,
Well, yeah.
Yeah.
We are done factoring, yes. So when you're done factoring, you just go to town. Whatever's the same on the top and the bottom. Not next to each other. These sevens don't cancel, right?
Right.
Anything's the same on the top and the bottom because then they really are dividing. So then they will die. So what dies? Big dude.
X
Big
squared,
dude.
yeah.
Dead.
X minus 1.
X minus 1. Dead. There's one more thing.
X. The X on the bottom of the X.
I like it. How many X's do I have up here?
4.
And I got 1 down there, right?
Correct.
So how many's left?
3 of
None down there, but 3 up there.
3 up there. I like it. So the worst part of these problems, given that you know how to factor, the worst part of these problems is keeping track of who's left. So the messier you are, and I'm pretty damn messy myself, but if you're messier than me, good God, it's going to be kind of difficult to keep track of who's still there. Yeah. Let me collect what's...
How'd you put that last part where it's x3?
Oh, 1x cancels with 1x. There were 4 up there, so how many's left? Or just 4 minus 1 is x to the third over there, right? So who's left here? We got an x cubed
X minus 3.
and an x minus 3 on the top, right? And who's on the bottom?
X plus 1. X plus 1.
Just x plus 1.
Yeah, you were pretty messy.
Thanks, Trent. I freely admit it. I feel bad for my students on what you guys keep taking me for. What did you just write, Jeff? I don't know. But the day that I can't write it, that's the day I'm going to give it up. Because I had a teacher like that. What'd you write up there? I'm not sure. Like, oh my God. If I ever get to that point, I got to give it up. All right, guys. Let me give you one to try on your own.
Okay.
Here we go.
Yay.
Let's see if I made one that works.
So it's gonna be AA plus something minus something plus something minus something. What is it? Plus 7 plus 8 minus 7. Okay? Yeah. And times. This is A. 2
So I've actually had people that would actually break this up into 4 problems
Right.
and then put it all back together. Because the biggest mistake people make is they forget something or they
A plus 3.
overlap something. The people who do this the best are the ones that realize, let me just do this by itself and get it done. Go to the next piece, get it done. Everything else doesn't matter at that moment. Only that piece matters. So I factor that first piece there.
It's just A minus 7.
Oh yeah.
I love it. It's a little thank God problem, right?
Yeah.
Which one? 8A.
What about down here?
8A. It's A minus 7. AA minus 7 plus 8.
Yeah, the big one's got to be positive and make that a plus in the middle, right?
Okay. So.
All right. We're on the top there.
How?
No, A's come out.
A comes out.
A squared plus
Yeah,
8.
because this is not cube.
Cool.
Yeah, that's what I told you. شفتي؟ صار لي ساعة.
And then A's come out of the bottom.
لأنه ما تدري هذا.
GCF then?
هذا شو
Yeah.
يسوي؟
No, it's not.
And then how's this factor here?
Get a. Yeah. A minus or A plus 7.
Yeah, they both have to be
7 and 8. Yeah.
plus. They can make a positive 15 in the middle.
Yep.
So this is a little cautionary tale here.
A plus 7.
What definitely cancels out over here?
A minus 7.
A minus 7's cancel out, right?
Yeah.
How about these A's? Yeah.
Yeah, cancel.
Right.
Yep.
And the A plus 7 here?
Yeah, with this.
Does anything else cancel?
Yeah.
This we can do it. Oh no.
Can this cancel with that?
No.
No, hell no. Not the one's not on the top,
No,
top and the one's the bottom.
How to make
They're
sense?
both at the bottom, right?
Right.
Is there any A squared plus 8s anywhere?
No.
So he's not the same as anybody else.
No.
So what's the answer then? It's going to be A squared plus 8 on the top.
And A plus 8 square.
Yeah, I like it, which you can write as this if you want to. So be real careful. The only time it can cancel is if they're exactly the same. Right?
Yeah.
9 divided by 9 cancels. With 9 divided by 8, no, they don't cancel. They got to be exactly the same. Cool. Okay, maybe. This is powerful.
Keep it non-toxic though. Just for you.
To make it feel special. All right. Let's do another one, and then we'll get into some other stuff here. Oh, let me ask you this. Okay. What can X not be? When is the following undefined? The minute I started talking about rational expressions, fractions, what can't be where in a fraction? Zero cannot be on the bottom of a fraction because like we talked about before, that's undefined. There's no number defined to do that. So when I have something like this, what can x not be?
0. No, -5.
Now here's the cool thing. Say in English, before I even wrote that, what did you guys just tell me? What can't be true in a fraction? The bottom can't be 0. What's the bottom here?
X plus 5.
Okay, so x plus 5. The bottom can't be.
-5.
The bottom can't be.
Oh, 0.
0. You guys with me?
Yeah.
Because when we get to, there's more advanced forms of this. And who can tell me, what is it that, we haven't really talked about this yet, but who knows that all the things that I can use to plug in for x is given a special name. Starts with a D. It's the what?
Denominator?
The domain. I don't know if you guys remember or have talked about that yet, but we will when we come back to do the function section. What we're really doing right now is figuring out all the values of x that I can use by saying what I can't use. The bottom can't be 0, so what x would actually make the bottom 0? X can't be -5. And of course you can see -5 plus 5 would make the bottom 0. Can x be 1?
Yeah.
Because the top can be 0, just the bottom can't be 0. So if you can say in English what the restriction is and then translate that into math, you solve it, there's the answer.
So x cannot be -5. That's the question and answer.
The question is what can x not be? When is the following undefined? That's more like what the book's going to ask.
Oh.
Give me all the values of x that will make the following undefined. Then you just set the bottom equal to 0 and solve it. Or set it not equal to 0, even better.
Right.
So what about this one? Of course, they're not all going to be that easy. What if I had this here?
Yeah. So wait for it.
Yeah.
That's just factoring.
Make this. Yeah. It's like, yeah.
Oh yeah.
And 90s.
29. So 29 make 180 when you multiply them, right?
Yeah.
And they will make -11 as long as the bigger one is negative. So why did you factor the bottom though? If it looks like this, it's easy, isn't it? Because if -5 plus 5 makes 0, I can just see it. This is stupid. It's hiding two answers in it. So if I factor it, x minus 20, x plus 9. Now you see why we did section 6.5. If I say that can't be 0, how do I solve that? Either
1 or
x minus 20 is not 0, or x plus 9 is not 0, right?
Yeah. So either 20 or -9.
Yeah, so you get x can't be 20, and x can't be -9. The whole other purpose for doing that section.
Yeah.
Exactly.
Exactly. Exact same thing, but what can't it be?
And that's the easier question, because easier answer for that. Because if I say what can x be, that sucks. It can be a lot of damn things. It could be 6, yeah, 7, yeah, 8, yeah, 2.3, yeah. Let me just tell you what it can't be, because it's a smaller freaking list. There's only 2 things it can't be.
Well, when you set it to 0, isn't that when you're finding exactly what it is? What it can be?
Exactly what makes that happen. You with me?
Okay. Okay. Exactly.
So I got to be careful. Actually, the way I worded the question, it should be x equal -5x. But you'll see in there what is the domain, or what are the allowed values of x. Then you say like x can't be -5, x can't be 20 or 9, -9, right? If I say what is the following undefined, then that would actually be x equal -5. That makes that undefined. With me? So I'm a little more used to the domain question. That's why my brain went straight to that. What makes this undefined? 20 and -9 makes it undefined. So what am I allowed to use? Everything except 20 and -9. And that's what I'm more used to saying. Because that's what I'd be more interested in knowing.
Does it have to be a not equal?
If the question says when is the following undefined, then you could just put 20. If you put not equal to, I love it. I understand that. That's awesome. Or in the book you might see this, and that's why, because those are the values that make it undefined. So those are the answers to that question, right?
Okay, got it.
I'd rather say it can't be 20, it can't be negative 9. That makes more sense to me. These are things it can't be. Okay. So you see that like on page, I think it's probably the first thing they ask you. Almost. Yeah, page 426. There you go. So they do use the not equal to sign 11. Starting at number 17 through 28. So here's an evil example of this. Can anybody tell me when is this undefined? It's never undefined, right? What's got to happen to make it undefined? The bottom has to be, but the bottom is
7.
and I have no control over the bottom. Do you see what I mean when I say that?
Right.
Here I got control, because my control is the x. I control it. I can make it whatever the hell I want to, except in this case negative 5. Can I control the bottom and change it to? No, the bottom is always 7. It doesn't care what I make x.
Could you reverse them and switch the signs?
No. Because that would still be the x up top. It'd be like x to negative 1, and it's really up top then. It wouldn't really make the x on the bottom.
1 over 7x? It would just make that a 1 and x. It would just go.
Yeah, you could. Yeah, if you want to, you could rate it as 1/7 x. So that works for everything. There's no value of x that I can't plug in there, right? So if there's a variable on the bottom, it might have some spots that it freaks out to make the bottom go to 0. If there's no variable on the bottom, how can it ever be 0 then? The bottom is freaking always 7. Well, what if x is 2? The bottom is 7.
Yeah.
Right? It doesn't care what x is, does it?
So whenever there's a denominator that's actually a number, then it's never
Exactly.
undefined.
Or in this case, what about, here's the evilest problem you can get with this. I think they give you one like this.
Oh, beautiful.
This is a very evil problem. Careful. Can you factor the bottom?
No, it's not a difference of squares.
No.
I like it. So that's kind of a hint as to what the answer might be. And now think about it. What's the smallest that this could be? You can let x be anything you want it to be.
2.
X plus 1, x
1.
Can't factor it like we just said. It's the sum of squares. If you make x 0, what is the bottom?
0. 1.
You with me?
Yeah.
If you make x 1 or negative 1, isn't the bottom going to be 2? Because negative 1 squared and 1 squared are both 1.
Right.
So the smallest the bottom could be is 1. Can the bottom ever be 0 then?
No.
No, so this is never undefined.
That is.
Because when I square a real number, it comes out positive, right?
Correct.
Or at least 0, but then I add 1 to it. Ain't no way it could be 0. But the same idea holds. If I have a rational expression, if I have variable stuff over variable stuff, and they say, when is this undefined? You translate the question to be, when is the bottom 0? If it can't be 0, it's never undefined. If it can't be 0, those are the ones you have to throw out. Because it can't divide by 0. Right? Okay. Just realize that that's just one more place where you might have to factor something. Okay. I don't think they get too much freakier than that. No. In fact, to tell you honestly, we just did 7-2 also. We did 7-2. 7-1 is a single fraction. 7-2 is two fractions sitting next to each other, where you could just cross reduce if you want to, right? Just kill anything that's on the top of the bottom. What do you think we do with this here?
So this is the next section? Is that right?
Still 7-2.
Still 7.
Yeah.
Yeah, I thought there was symbols.
Yeah.
Now again, remember, variables are just numbers that don't know yet. They have to act the same as numbers because they are numbers. So what do you do when you divide fractions?
With the reciprocal.
Multiply by the reciprocal. So same thing you do here. So they're going to have some division problems in there. It's not really a new thing. It's just got one extra step. Just flip the damn thing.
Yeah.
It's nothing new. And as you flip it, you can save a little time by factoring. What comes out of here?
2.
Careful. No x's can come out, right? But a 2 can come out.
Yeah. X minus 4.
What comes out of the bottom?
2. X plus 1.
I like it, right? Is that cool so far?
Yep.
Yep.
Now, you guys cool with it? I'm going to flip this, right?
Yeah.
Let's see if you guys can handle this. Now, if you factor this, it's going to be on the top now. Right? It's going to flip.
Yeah.
How do you factor x squared minus 1?
X minus 1 times x plus 1.
Right, it's a little thank God problem, little difference in squares. X minus 1, x plus 1. And how do you factor what was the top, what will now be the bottom? Because I'm multiply
X minus 4, x plus 4.
by reciprocal. Yeah, exactly. X minus 4, x plus 4. So division problem is not really a different problem. It's the same problem. It's still multiplication. It's just multiplied by the reciprocal. And now what cancels?
X plus 1.
Okay, x plus 1.
X minus 4.
The 2's go out.
2's, yeah.
X minus 4 goes out.
That's it.
And what's left alive?
X minus 1, x plus 4.
Who got it?
How we doing? Somebody decent? See, so like I'm saying, if you're able to factor, this should be kind of easy. Yeah, I know. It always seems easy.
It's always easy when you're doing
The
it.
teacher's up there doing it. Yeah, I know.
When I do it, I'm like, shit, what do you do?
Oh.
Your phone knows so I can give you a call at 12 o'clock in the morning. When I do my homework.
Jeff,
Yeah.
do you mind reviewing what you did on the last step on that? I had to step out.
Here?
Yeah.
Cancels. Are you good up to here? Or where were you at?
I was right before you started canceling. I was right there.
Oh, so kill the a's. A plus 7's gone. A minus 7's gone. But the a plus 8's, there's no a plus 8 up here. There's an a squared plus 8. Right? But there's no a plus 8 on the top and the bottom.
Right.
So there's no a plus 8 that can cancel. This stays here, and these two stay there. So you can write it like this, or you can write it like that.
Oh, okay. Okay, this. Okay. A plus. Yeah. I thought that was a multiplication.
Just out of curiosity on that one that you were just showing him.
Yeah.
Could you? Is it okay if you like multiply the a plus 8 to the a plus 8 since they're the same or no?
Here's the thing. I'm glad you said that. Don't multiply anything out. Leave it factored because that's the only way you can make sure that you actually finished it. Don't actually multiply this out. It's kind of like going backwards.
Okay.
Leave it factored. Normally, the next step you would take if this is one part, because you know what's going to happen in the future, you're going to have a longer problem where this is just one part of the problem. And then you got to do more. Most of the time, you're going to want to leave this factored. Trust me. So don't waste time multiplying this back out. There's no point to it.
The reason I was confused at the beginning is because you still have two things squared. I was like, what?
So here, guys, hopefully enough of you actually brought your book today.
You know what I mean?
Yeah.
Maybe I'll just write them up on the board. Looks like a lot of us are bookless.
Even though, is it basic? No, I'm sorry.
So I want you to try these problems out here. On page 426.
Okay, I don't have books, so let's see. Not like that.
Number 18.
Number 18.
This will be, when is it undefined? 18 and 23.
It's a 3Z.
Yeah, it's a Z. And then this is just reduce. Number 39. And let's do, that looks gross. Let's do 2. Oops. Don't freak out. You can't reduce 23. They're not asking you to. They're only asking you what is it undefined. Nothing will cancel, trust me.
What is it? That's it? When z equals 0. Right here? 23. Right now. Plus 2. Oh no, having that big
First right and then
so
first left.
undefined
Yeah.
when z all of this so
Oh, totally I see.
I need to see how to
When did she come in class?
I didn't see it.
I didn't either.
let's see like a beer
I just I'm a little
I'm
bit.
into it
18, I see was
I like it here how it أنا هاي وسنوني جنوني يلا خلينا هاي الشيء راح
Put
تسوي
a lot of freaking work.
كتير
Really?
ناخذ
What's up?
Is this our homework?
Could be. So if you're, it's part of your homework, you're getting some of it done now.
That's right.
I like doing it at midnight though.
5 times that it can be
All right. Hide your notes from yourself. Really good. Do your homework.
ناخذ
Did it last time.
Yeah. Pretty good.
وين رايحة؟
Just call me over if you need some help.
ناخذ
I can. Yeah. Go ahead.
زين
You can ask people near you for help if you need it. Yeah. I'll have to make it all pretty. You're not going to turn these in. This is just for practice right now.
I know, I don't know how you بعدين when I nice next slide I'm going to go minus bracket and I'm like I know mom
So if you can't solve that equation, you have to do what?
it's a 39
What? Subtracting would be
oh
more
شنو هاي number 6
funny.
oh yeah no ميريتها قال بس هيك
So show me that equation.
yeah 39 6
The
and
equation you're talking about is
minus
5
هذي أساس اليوم ما أجاني
subtraction cancel addition. This is
الله حتى مصباحي
so we're gonna do the cancel multiplication. Division.
ناخذ هنا بس الثاني
Divide both sides by 2.
ناخذ 7 مستوى minus
On the other side.
فيها
0 divided by anything is 0. If you think about it, what do you multiply by 3 times the bottom of your equation? The other side is negative 2. 3 times negative 2.
21 minus
Can't be 6
22.
of 7 or 5
So
of 7.
ايه هنا يصير ايه هنا يصير بقى بس قدام يساوي من 3 وعلى الام راح يطلع يساوي من 3 يطلع فيه 17 ايه ما هي
Two signs. With the right idea, then you can see what can and can't be. Here, yeah, that's the idea. Same idea here. Yeah, you're on the right track.
لا مش بصبغ بعدين بالسيارة علي خلاص بقى على تليفوني بقى علي على السيارة ايه
Back at that, back at the bottom, times a over n plus 2. That would work the way integers
وديت
are
الهنا
squared. So you have an m and m will become squared.
يعني سنتين
It's not squared. What's the thing you always try first though? What do you always try first? What comes out of the way? 8, so you can take an 8 out.
God damn it, motherfucker.
Because you automatically
No, I'm trying
arrive
to do it
at the
right now.
bottom
What
can't
first
be
time?
what?
23. Did you do 23?
0.
Yeah.
But what's the bottom?
انا هذا بعد ما
So
جاوب
M
3z
can't. Oh, what did I do?
can't equal
I got
0.
to FOIL out the bottom. That's all.
Well, now you gotta
just
solve
do
it.
the bottom part.
But see, that at least sets
And
up what you're trying to
just
solve.
equal to the
Because
Z.
you don't want to let the bottom equal 0,
And
right?
then M cannot
The
equal
bottom not equal
3
0. Now
or
how do you
2.
solve for z?
-3 plus 4.
So what's the damn
What operation right now is there between the 3?
Yeah, because
Oh,
then with 3
I
minus
see.
2.
So write it better. Write an equation. 3z equal to
هنا
this
نحسب
line.
زوايد
3z not equal to. Make it a
The
little
sum of these is 1.
3z
The
not equal to.
product
Yeah,
is
now solve. What operation is it? The 3 and the z, what operation? What's the 3 and the z doing to each other? You know, they're sitting right next to each other, so what operation is it?
never
Are they adding? If they were adding, what sign would be in the middle?
okay let's go to the other one okay
If they were adding, what would be in the middle? So
46
plus sign.
هذا شنو هاي
They're sitting
46
next to
شو
each other, what operation is it?
M cannot equal -3 or 2.
20 هاي page 453 هسه
If I wrote this,
page 453
the 3 and 2 sit next to each other.
number 655 46
Yeah, so what's what do you do? How do you kill the 3? You
Yeah.
have to multiply. What's the opposite of that? All you're doing is solving that middle equation. You're trying to get z by itself. So you divide the 3 over. Divide both sides by 3. And 0 divided by anything is 0. Now you gotta be careful here. You are right in the fact that you gotta get these to be the same so they'll cancel, but
هسه هنا نقدر
you
نسوي
only get
cancel
2
صح؟
minus m, not m
So you
minus
got
4.
6 sevens.
هي هنا نقدر نسوي cancel
So what you took an 8 out and you notice it's the wrong sign. So what should you take out? Not just an 8, you should take out a negative even. That would switch the signs, right? But I'll do that one up here because that one's a little weird. Because what would be left?
هاي
It would
نقدر
be
نسوي
2
هنا
minus
cancel
m and it's not the
وانت
same as this.
خلينا
But if you take a negative into that, the m becomes
لا
positive.
تلزمي never واحد
Negative
يجاوب
a,
ما
negative
يحل
two. And the m becomes positive. Yeah, then
هاي
it would be
نسوي
then it
cancel
would
لا
be 3.
تلزمي نكتب
Yeah. You have to be there. Right now, if the m is too negative, right, you take out an 8 and then take out a negative in.
ليش؟
Now they will cancel.
لا
That should be a negative 8.
نسوي cancel هنا
That's
نبي
why.
نكتب uncounted
So m minus 2 is gone.
هذا في 7 هذا في 8
No, you can't. You have to wait until you're
Let's see. So you kill
هذا 4 شنو في جديد بسنة 28
they're going to do. You can actually cross through this here too. But eventually, I mean, it doesn't really matter at that point. done enough that it makes the last thing not good.
ستة
Cool.
على اثنين فيها 12 14.
I'm trying to do that right now.
52 is the first thing to do, you know. I'm still trying right now. Just found out I got a job I'm doing, so. Yeah.
Nice.
Congratulations.
You shoot darts? Is that what you do?
No.
Let me try to lead you along. How many terms are there on the top?
Three.
The first number is a not a 1.
Not a
It's a
1.
7.
So you do the sugar.
Yeah. Trying to do
Yeah.
that right now.
That's what I needed.
This brain doesn't work today.
I'm telling you, man. Okay, so it's
You doing okay?
negative 450.
Beautiful. Now you just GCF This is where people get, they sort of bring this into world. You're not done factoring this out. So don't think about anything
فنانة
else
هاي
except
قريبة باي فاتن
GCF that, GCF that.
5.53
Or shift if you want.
هاي number 6 12 and 5 على 5 على 6 اختصارات الكالكوليتر اختصار
And that's a 72.
يلا
So it should be a 72 plus 4. Anybody have a problem? Good job, man.
هاي
I found the right factor. It's negative 140 yet, too.
Oh.
I haven't found it. Have you found it?
Yep.
35. Oh, you felt cool. 35.
He was banging on the calculator. He's like mad at me.
Oh, you don't even know. I'm just like, what the hell? What do I do? I
You
don't
know the
know.
middle number is big, so you knew that one of them had to be big and one small.
Yeah.
So
But
just start taking 140 divided by 2, divided by 3, divided by 4, and you'll hit it.
Ah, there you go.
Divide by small, because you know one has got to be big anyway. You'll get it. That's the most common way to do it. It's relatively quick.
140 بعدين نحللها اثنين كيف رقمين بس شو يصير هنا يصير so grouping
And then from there we do grouping, right?
minus 140 minus شنو 40
Right here, you're going to take an 8, right? And then you have a 2 minus m left. And it won't cancel with an m minus 2 because they're not the same. It doesn't stay that way because you can do something to make them the same. What's wrong with them? Why aren't they the same? So what can you take out to make something change? Signs. What do you take out of something to make it switch signs? A negative. Don't take an A out, take a negative A out.
Right? Boom!
oh, I got this stupid thing.
Alright guys.
Yeah.
I think a lot of you guys hit 52 as a little bit of a snag.
Yeah.
Brain fart.
And I think this one's got a little bit of a weird piece to it.
Those are all on page 433. All those.
Yeah, they are.
yeah we can cancel those
Number 46 is one of the straightforward problems on